Hello children, we are starting chemistry today and the topic is some basic concepts of chemistry. If someone asks you to define chemistry, you may say in a simple sentence, chemistry is the science of atoms and molecules, and that is correct. However, a more polished definition is a branch of science that studies preparation, properties, structure and reactions of material substances is called chemistry. Here the keyword is material substances. So most of the time we will talk about material substances. Now we will talk about matter and material substances. So the question is, what is matter? Anything that has mass and occupies space is called matter. For example, pen, pencil, table, chair, this board, this wall, this camera, you and me, everything is matter. There are three states of matter: solid, liquid and gas. And their detailed properties we have already studied in previous classes. If you need a refresh, you can go through my class 9 chapter 1 video, that is matter in our surroundings. Link is given in the description box below. Matter can be classified into two categories based on its physical properties and chemical properties. Physical properties such as color, odor, density, melting point, boiling point, etc. And chemical properties such as chemical composition, combustibility, reactivity with acids, bases, etc. Based on physical properties, it can be further classified into solid, liquid and gas. And based on chemical properties, it can be further classified into pure substances and mixtures. In pure substances, all the constituent particles exhibit the same composition. It can be further classified into elements and compounds. In elements, all the particles are of same type and they show the same nature. For example, carbon, hydrogen, oxygen, nitrogen, etc. When two or more elements combine in a definite ratio, they make compound. For example, H2O, water molecule, in which hydrogen and oxygen gases combine in 2:1 ratio by volume to form a water molecule. Mixtures. When two or more pure substances combine in any ratio, they form the mixture. In any mixture, these pure substances are called as its components. Mixtures can be further classified into homogeneous mixture and heterogeneous mixture. In homogeneous mixture, these pure substances means these components completely mix with each other so that the constituent particles exhibit the same composition throughout the mixture. For example, air, sugar solution, salt solution, etc. If that is not the case, the mixture is called as heterogeneous mixture. For example, grains and pulses are mixed together and they have some dirt particles and stones, etc. Another example can be when you mix sugar and salt. Physical properties can be measured or observed without changing the identity or composition of the substance. On the other hand, to measure or observe chemical properties, a chemical change is required. Now let us see laws of chemical combinations. There are 6 laws. We will see them one by one. First one is law of conservation of mass. It was given by Antoine Lavoisier in 1789. As per this law, matter can neither be created nor destroyed. There is no net change in mass during the physical or chemical change. And in a chemical reaction, total mass of the reactants is equal to total mass of the products. Let us see one question based on this. 10 grams of calcium carbonate when heated produces 3.8 grams of carbon dioxide and 6.2 grams of calcium oxide. Show that the result is in line with the law of conservation of mass. So the chemical reaction will be something like this. CaCO3 when heated will give CaO plus CO2. Now it is given that mass of CaCO3 is 10 grams. So write 10 grams here. Produces 3.8 gram of carbon dioxide. 3.8 gram right here. And 6.2 grams of calcium oxide. 6.2 grams of calcium oxide. So as per this law, total mass of the reactant must be equal to total mass of the products. So let us add 6.2 and 3.8. 6.2 and 3.8 will give 2 plus 8, 10. 0, carry over 1. 1 plus 6, 7 plus 3, 10. Means total mass of the reactant is equal to total mass of the products. So the result is in line with the law of conservation of mass. Second one is law of reciprocal proportions. It is also known as law of equivalent weight. It was given by Richter in 1792. So let us understand what is this. The ratio of weights of two elements A and B which combine separately with the fixed weight of the third element C is either the same or some simple multiple of the ratio of the weights in which A and B combine directly with each other. This sounds complicated. However, it will look simple when we take this example. Suppose my element A is carbon, B is oxygen and C is hydrogen. Atomic mass of carbon is 12, hydrogen is 1 and oxygen is 16. When carbon and hydrogen combine, they make CH4. When oxygen and hydrogen combine, they make H2O as per this reaction. So let us calculate the ratio of their masses when they combine. So ratio of carbon and hydrogen when they make CH4 will be C is to H will be equal to 12 divided by 1 into 4 means 12 divided by 4. So 12 is to 4. Ratio of oxygen and hydrogen when they combine. So it will be 32 is to 4. So ratio of oxygen is to hydrogen will be 32 is to 4. Now we have to fix the mass of hydrogen with which carbon and oxygen combine. It is already fixed. So let us say it is 4 gram. So with 4 gram of hydrogen, 12 gram of carbon is combining. With 4 gram of hydrogen, 32 gram of oxygen is combining. So ratio of carbon is to oxygen when they combine should be 12 is to 32. 12 is to 32 or a simple multiple of it. So let us verify when carbon and oxygen combine together. So ratio of C is to O. From here it should be 12 divided by 16 into 2 means 32. So 12 is to 32. You see the ratio of their masses is same as this or it could have been a multiple of 12 is to 32. Means law of reciprocal proportion holds true. Third one is law of definite proportions. It was given by Joseph Proust in 1797. As per this law, a given compound always contains exactly the same proportion of elements by weight. This law is also called as the law of definite composition. In a water molecule, the ratio of hydrogen and oxygen will always remain 1 is to 8 by weight, whether it is tap water, river water or sea water. Fourth one is law of multiple proportions. It was given by Dalton in 1803. So let us understand this law. If two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in the ratio of small whole numbers. So we will understand this more clearly with the help of this example. Suppose hydrogen and oxygen combine to make two compounds, water and hydrogen peroxide. When they form water, the chemical reaction will be like this. 2H2 plus O2 makes 2H2O, and when they make hydrogen peroxide, the chemical reaction will be like H2 plus O2 makes H2O2. Ratio of hydrogen and oxygen in water will be 4 is to 32, and ratio of hydrogen and oxygen in H2O2 will be 2 is to 32. Now fix the mass of oxygen in both the compounds. That is already fixed here. So ratio of hydrogen will be 4 is to 2 in two compounds, that is 2 is to 1, which is a simple ratio. Fifth one is Gay-Lussac's law of gaseous volumes. It was given by Gay-Lussac in 1808. So let us see this law. When gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. Suppose two gases, hydrogen and oxygen, combine to make water vapor. Two volumes of hydrogen will combine with 1 volume of oxygen to make 2 volumes of water vapor. That means 100 ml of hydrogen will combine with 50 ml of oxygen to make 100 ml of water vapor. So the ratio of hydrogen and oxygen will be 100 is to 50, means 2 is to 1, which is a simple ratio. Last one is Avogadros Law. It was given by Avogadro in 1811. So let us see the law. Equal volumes of all gases at the same temperature and pressure contain equal number of molecules. We will see its application going ahead. Let us see Dalton's atomic theory, which he had given in 1808. It was a four-pointer theory. Point number 1, matter consists of indivisible atoms. Point number 2, all atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. Third point, compounds are formed when atoms of different elements combine in a fixed ratio. And the fourth point, chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reactions. There were some drawbacks in Dalton's atomic theory. We will discuss them point by point. First point, he said, matter consists of indivisible atoms. With the discovery of subatomic particles like electron, proton, and neutron, it was clear that atoms are no longer indivisible. Second point, he said, all atoms of a given element have identical properties, including identical mass. With the discovery of isotopes, it was clear that all atoms of a given element may not have equal mass. They may differ in mass. Third point, he said, compounds are formed when atoms of different elements combine in a fixed ratio. He could not provide the reason why atoms combine. And the fourth point, he could not explain the law of gaseous volumes. In next video, we will talk about subatomic particles, atomic number, atomic mass, and mole concept. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.